CSC410 computing ethics course. This is the official plug for that course. So now all the Ann Arbor folks are wondering, what did we just spend the last 5 minutes talking about? Correct answer is nothing. Okay, a couple announcements. I sent out an email about it. Well, first of all, this Wednesday night, 6 p.m. in the same place as last time is our next Tech Talk that you are cordially required to attend. This week's speaker is a guy named Antonio Fernandez. He is the, I think, Director of Emerging Technologies or something like that, or Vice President of Emerging Technologies for Tesh Global. We're also going to have the CEO of Tesh Global, I think, in maybe two sessions from now, something like that. That's Will Tesh. But this guy will talk about all these emerging technologies that they work with, and really kind of focusing on this idea of, especially in, with technology, every 15 seconds we have something new that comes out, right? How do you figure out what's going to be the next big thing that you should, at a corporate level, really dedicate your resources and time towards, versus what's going to be one of those things that, pops up and dies out 2 months later and you might spend a whole bunch of money on. So you can kind of talk about some of those things. So I think it should be another good talk. The other blame if the food sucks. That would be, have you even thought about food yet?
A little bit.
Okay.
There we go.
So it would be Jack if for those Ann Arbor people. All right, so the other thing I posted on Slack and I also emailed about is CU Launch. It is the first session. There's only 3 sessions for it. I don't know the dates for the next 2. They usually don't tell you the dates until you come to the first one. But they usually last 2 to 3 hours. You only have to show up 3 total times. And there's like $5,000 in prize money. For the last several years, CS people have won the event.
Really?
Yeah, I mean, Maddie and Grace won last year.
Okay.
Yeah, they won $2,500 for the first place prize. Yeah, so let me give the overall pitch for it first, and then if you have questions, you can ask. But so the idea here is that it's effectively to train you on how to be an entrepreneur. Okay, so a lot of you know that's kind of my background. I've started businesses and sold businesses and things like that. I was doing that since I was 18. Now, that may or may not be your dream, but at the very least, what CU Launches is a free way of understanding what that world is like, what it takes to start a business, and probably more important, teaches you on that idea of, most businesses do fail. So I've had basically 5 big wins, but I've probably started 50 businesses. And I'm at any point in time, I'm part of 5 or 6 different startups where I'm mentoring them or something like that, and almost all of them are going to fall apart. But each one you learn the next little nugget, right? And sometimes the goal can be making a bunch of money. One of my early startups, when I sold it for a couple of bucks. That is don't have to work again money. So I mean, this is something that you can get out of this skill set, because especially in technology, we're all dreamers. So most of you have sat around before and say, oh, I wish there was an app for that, right? Now, sometimes you say if this app existed, you would use it, but also from a consumer perspective, we don't like overpaying for apps, right? So part of the business model idea of entrepreneurship is, here's a great idea that if it existed, people would use it, but how do we pay ourselves for creating it? And you have to figure out, where does the money come from? Because a lot of times the money's not going to come from the end user. The money's maybe going to come from the person who's going to get it in front of the end user, who maybe is going to pull some data about the end user's usage or something like that. So what CU Launch does is it encourages you to show up. You don't even have to have an idea. You could just be interested, and you'll hear some other people talk about the ideas that maybe they have that are probably going to fail as a company. That's okay. Most fail. But unless you fail a bunch of times, you're not going to maybe have that big win. But maybe you'll get the creative juices going, you'll come up with an idea, or maybe there'll be somebody else there. I know a guy from the 250 class, Noah Kurtz, has a good idea. I don't even, and he has like 4 or 5 ideas he's been working on, but he has an idea, something related to database, and he's looking for some folks that are interested in pitching it with him. So that seems like it might be up your alley. Look them up on Slack and say, hey, I heard you have a database project, tell me more, something like that. Bottom line is, you go to this thing, you get free pizza, free soda. They give you a free book called the Mom Test that teaches you the kind of this entrepreneurial idea of how do you vet your idea. You know, if you remember from our talk from a couple of weeks ago, Mike was up there and he was talking about the sea cucumber, right? You know, how, you know, they went to, was it China? And decided, oh, we need to have a sea cucumber shop in Mequon and all this stuff. Well, in the end, they built it, they did all this stuff, but they never actually asked the question of whether they should have done it. And in the end, it was a failing business, right? So they teach you that prospect of how do you, the process of how do you vet that idea? How do you go through an initial spark and decide, is this something we should actually do, or do we, you know, then you have all the entrepreneurial speak where like, oh, we pivoted our idea to stuff like, because you have these serial entrepreneurs that just go and do all this stuff. And at the end of the day, it is fun. But the Mom Test is kind of a mentality for how do you vet your ideas by talking to people using certain language as if you were having a conversation with your mom about your idea. You know, like, for instance, one of the taboo things is you wouldn't go up and just say, if this existed, would you use it? That doesn't give you meaningful information. So they teach you other things you can do from that. And then ultimately they give you these easels that have some, you know, this thing called the business canvas on it. And they have you start putting stuff like, you know, who are my customers? Who are my investors? You know, where does my money come from? You're putting stuff in these different categories, and then they'll have mentors come around and give you some feedback and say, oh, well, so that's how your business works. Have you thought about maybe this person being part of your business? Maybe insurance companies would be interested in what you're doing, something like that. So you get to kind of go through this ideation process and learn some stuff. Punchline is you can get some cool experience, cool knowledge out of this, and even get some money in your pocket. But don't do it for the money. The money's nice. It's good prize money. You don't have to build the business out of the money. Grace and Maddie, they won it last year, and they decided they were going to do the business, and they decided once they got their jobs, they didn't have time. So they dissolved it, each pocketed, I don't know, $1,000 or something like that, and moved on with life.
What was your idea?
They were doing this app called HBU, that it was the same thing they presented at their senior seminar project. So it was, you know, a mental health tracking app type thing. You guys didn't do CU Launch last year, right?
No, but we use a lot of the same stuff.
Yeah.
The Mom Test.
Right. Right, yeah. So Blaine and Austin, last year, they were working with nursing on a VR project, who they are doing CU Launch this year, by the way. So if you're interested in connecting with them, if you want to continue on with that through CU Launch, you can think about it, but I'm just throwing that out there. You know, but they went and they got some grant money, not through CU Launch, but through, their real initial vertical was through the Smart Cities competition thing, where they got to round 4, and they got a couple of grants from that, and then that let them get some funding from the university and some other things. But you know, it's a good experience to get those things. You throw it in your resume, it makes you look good. You're co-founder of company XYZ, whatever. So strongly encourage you to set aside 5 to 8 p.m. on September 24th. It's in the same place where our tech talks are, and come to that. It's at least come to the first thing. If you end up hating it after that or didn't like what you hear, don't come again. But come to the first thing and at least get a feel for it. This year they're actually creating an IT-specific track. So they have money set aside just for ideas associated with technology. Yeah. All right, questions about that or comments or anything else? I'm not requiring you to do it, but it's potentially free money and it is free food, so don't be stupid. Go to it. All right. Most of what you'll learn in college, you won't learn in the classroom. You learn by giving yourself opportunities outside the classroom. Okay, so homework for today. Oh, and I guess I'll say this for the video. If any of the Ann Arbor folks are interested in this type of thing, I can help facilitate a remote participation in it. I think I can probably pull that off, and I'm pretty sure Dr. Dan Sem, the dean of the business school, would be in favor of that. In fact, that would actually be really great if one of our remote teams won and just put the rest of you guys to shame. And if any of you have an idea or want to sit down and talk about potential ideas, I'm pretty good at coming up with ideas. So questions I would usually ask you are like, what are your hobbies? What's something that you, that maybe you do by hand that you wish, there was some kind of automated solution for. I would kind of take you through that ideating process of getting you to almost come up with your own idea. And usually over a 20 or 30 minute period, you can usually come out with at least the initial spark of something. So if you want some help coming up with something, I'm happy to sit down and help you through that. I can even, help you be part of your business as your mentor or something like that. I'm part of like half the businesses that come out of CU Launch. It's just fun, and I know most of them are going to fail. I don't care about the dollars. It's just a thing. All right. So homework was the sort on predicate. Mm-hmm. This guy. Okay. So this is going to be pretty similar to what we had before, right? Except instead of just blanketly asking less than, we're going to be checking against a predicate. So for instance, here's sort on predicate less than, where it's going to apply that predicate to, each value. Is this guy less than this guy? What's actually interesting is by definition of a predicate, this actually kind of breaks the core definition of predicate. I've taught you predicates are functions that take a single parameter and produce a Boolean output, where less than actually takes two parameters, right? Mm-hmm. You would have it take two numbers and then spit out a Boolean. So you can amend your predicate definition, I suppose, to taking in any number of parameters and returning a Boolean output. That would technically still be a predicate, because really predicates, if you notice, the naming convention for them typically have the question mark at the end of it. Mm-hmm. So typically a predicate is a function that would return true or false. It is a functional equivalence to a Boolean expression. Okay. And really, this particular guy is assuming that the predicate does take exactly two parameters.
I was going to say, you can't just throw any predicate in
Yeah,
there.
right. In this case, it has to take exactly two, because you're replacing effectively what would have been less than with greater than, or, we can create a predicate for is a power of, something like that. All right, so here's our merge sort here. And let's see, we're slicing up the thing. We're calling where's our merge step? So really, we're just going to update our merge step. So our merge sort itself, we'll just break merge sort. This guy's going to take a list and a predicate. All right, and this guy is going to then pass that on to the merge function. So the merge function will take two lists and a predicate. And what is he going to do? He's going to go through here, and right here where we ask the question about being less than, that's where we'll pass the predicate in. And the rest of it should be the same, so we can pass it less than as our predicate. That guy is a lambda. Oh, my merge takes an extra. Remember, I added predicate to my merge. So whenever I call merge, I have to pass it. Oh, this was my test for merge, so I don't even need this guy anymore, right?
Should you pass those things within like the merge function too?
Well, I did. Merge sort is here, so whenever I call merge sort, oh, you're asking about this. Yeah. So I need to pass my predicate along anytime I call merge sort. And I need to pass my predicate along anytime I call merge.
And also up there you need to pass it too.
Oh, yeah. He's watching that.
I do the same thing. So.
All right. I think that should do it. So we updated our merge to take a predicate now. It takes a third parameter. So whenever we previously called merge, make sure you pass it the third thing. We also updated our msort to take a second parameter. So whenever we call msort, make sure you pass it that extra parameter. And here's the extra parameter for call to merge right here. All right, so there's that guy. If we wanted to pass it a different predicate, we can do
The same one in.
huh?
You type in the same thing.
Oh, did I? If I wanted to pass it a different
It works, see?
I think it works flawlessly, just flawlessly. All right, that makes sense? All right, so what was this question really drilling? So first of all, it was an easier question, right? But it made you go through our implementation of merge from last class, so hopefully, or msort from last class, so hopefully at the very least, if last class you were struggling to follow what we did in class, this forced you to go through it and understand what merge and msort, how they work. But what was this really teaching you? What was it testing or drilling into you? What new thing or what thing had you heard of before that you now maybe have a better comfort level for? Probably this idea of passing around functions as parameters. We've called a lot of recursive functions, right? Where we call a function within a function, but we haven't done a ton with actually passing a function as a parameter outside of map, right? But map has already been something that's a little bit tough for us to kind of think through. Some of you have caught on to map pretty well, but I've kind of encouraged you not necessarily to use map yet because it can be a little frustrating when you're thinking about mapping a function across every element of a list because we're just not that comfortable from where most of us have come from programming wise with the idea of passing functions around as parameters. We're used to passing around ints and chars and strings and data types as our parameters. And we don't think of functions as data types. But now I want us to start thinking about functions as data types because if I were to define an int here, define I to be equal to 0, I is going to be an integer and its initial value will be 0. I'm defining that integer, that variable, identically to how I'm defining a function. The value associated with I is a number. The value associated with msort is a lambda. A lambda is an unnamed function. Go ahead.
Okay, I don't want to get ahead of us if this is too lofty or something to get into, but
So you mean if the rest of the group is too stupid to get it, you don't?
If I want to define something within another definition of, so if I want to have a local variable, there's the local keyword. I could not get that to work. I don't know what I was doing wrong, but defining something locally inside of another definition.
Okay.
I don't know if we need to go over that now or not.
Yeah, we're going to accomplish that through something called a let.
Okay.
Yeah, we're going to give ourselves a kind of a local variable environment through something called a let. So let me actually quickly show you the definition of a let. Isn't that in the notes from last time?
What are the notes?
Or did I just tell you that, hey, we need to talk about lets?
You just told us.
Okay. Local environment. Did I spell that right?
LET is perfect.
All right. Huh? This is why doctors have bad handwriting. You could barely make out the L in my signature. You can make out the M. It's just an M with some squiggles and a little zippy doo at the end. All right, so we actually have two versions of this. We have something called a let. In fact, I'm only going to show you the let now. I'll verbalize the other one. We have this thing called a let rec, and a let rec allows us to make recursive calls on an environment. Okay? We don't have a context for that right now, so that's why I'm not going to show it to you yet. But it would be handy for us to create lets. Okay, so we're going to create a local environment and then do our logic within that local environment. Okay, so the definition for, or the syntax for a let is let, that's the function name. And this guy takes a list. And what this list is a list of two lists. So actually, let me throw you the last part of it. So then it takes in the body. So this is the body of our let function. And what the body is the logic. This is the stuff that we want to accomplish in terms of the local variables we define inside of there. All right, so this second parameter of a let takes a list of two lists where each two list is a name value pair. So for instance, I can say I5 J or well, B B6 actually let me write this more generically. So I'm going to say var name val I'll just put some dots, the ellipses in between there, so you can have as many, I guess you technically could have 0 variables defined in your local environment, but then I would start really questioning why did you create a local environment if you didn't need to define variables.
Consistency.
All right, so now let me show you like an example of this. So we're going to define let test to be a lambda that's going to take in nothing, just because that really drives the point home of what I'm trying to do here. And I'm going to create a let environment where I have, so there's my parameter list, and my list here contains a bunch of two lists. So I'm going to have A is equal to 5, and I'll have B is equal to 4. All right, so I have two variables defined inside of my local environment here. And then I'll go ahead and return plus AB. So this will, I've defined a local variable called A equal to 5. I've defined a local variable called B equal to 4. And the body, so that's the first parameter of let right there. Here's the second parameter of my let right here. That's the body of the let that is operating on, or at least has access to, these variables I defined in here. So this is going to give me a 9. Well, I need to call it, but you know. I'll just call let test. It takes no parameters, so I won't pass in any parameters. And there is my 9. If I change this to a different variable, or a different value rather, I get that kind of stuff. Now, I can also say add plus, well, actually let's call this guy double. Here, I'm going to back up here for a second. I'm going to put, there's actually a third one called let star. I'm going to show you that one here in a second too. So I'm going to say A5, B4, and then we're going to say add is a lambda that takes an X and a Y and adds X and Y together. So my let environment has 3 variables I've defined. I've had a variable named A is equal to 5, a variable named B is equal to 4, and then a variable called add that is equal to a lambda.
This answers my question of how to define a function inside a function.
All right. So now I could say add AB. Well, you're making the assumption that my code's going to work here. So there's my 9. That make sense? Again, functions are values just like a 4 or a 5. They're just values. They just look scary because you got this word lambda in front of it, which just seems intimidating, right? All right, so is that clear what that guy does? All right, so now let me show you a what if I want to do this? I want A to be equal to 5. I want B to be whatever A was plus 4. And then I want this add function just because. In fact, let me, well, whatever, I'll leave it there. I will leave an add. So my ideal output here is 5 plus 9, which would be 14. That's what I'm hoping to accomplish here. But it's going to scream at me. It's telling me, hey, wait a minute. I don't know about a variable named A. And I'm going to say, but I just defined it here. Let's going to stay. Let does not allow for that. Let star does. Let star says allow you to define variables in terms of other variables that were defined inside of the let.
So that saves you from having to nest a bunch of lets. Okay.
Yep.
So basically, it's better to do let star.
Who?
No, I was just wondering. So it's basically it's better to use let start for everything.
This would kind of fall into, so she's asking whether it's just always better to use let star, is what you're saying. Better is relative. So it's never going to be wrong to use let star. This kind of goes down to that thing of, do we use the equal sign? Do we use the EQ question mark? Do we use the EQV question? Is it EQV question mark or just EQV?
EQV question mark.
Okay. Or do we use equal? Equal is like the super powerful one, right? So you can just say, I'm always going to use equal. Equal is also the most inefficient of them because it's really looking under the microscope, let's say, when it's checking for equality between two things. Same thing would be true here. A let star would be less efficient than a let. Go ahead.
Does let star open up kind of maybe some security issues?
I guess I don't know. I'd have to think about it. I don't necessarily think so, or at least nothing that's seemingly obvious to me. when you run this, so let's say you have b is equal to 4 here. We actually don't need a let star in order to accomplish what we have here. But we can use a let star. It's not going to hurt anything. You know, this guy still functions. But if we just say let here, let's say it runs in, I'm just going to use seconds to keep things simple. Let's say that runs in 3 seconds. That's how long it takes to run. A let star might take 4 seconds to run. It takes longer to execute because what it's having to do under the hood is more complicated. Even though in this particular case, it didn't actually have to do anything special. And I think they also have to be in order. This would be interesting. Does it make 2 passes? Well, let's just run it real quick. I think it does make 2 passes. Okay, no, it is in order. So you can't define A in terms of another variable that isn't defined till later. So you do need to define them in an order. It could have done this in 2 passes. That would have been quite a bit harder actually for an interpreter to accomplish that, because the variable has to happen during runtime instead of just giving you a pointer to where to find it. So bottom line here is that a let star is better than a let, we can say, from an accuracy perspective, but I would encourage you from a learning perspective to always use the minimal tool that you need for the job. At the very least, that'll encourage you to really ask those questions of what am I actually trying to accomplish here? That make sense? Now, I guess while we're at it, let me define Factorial. I'm just going to show you Letrec just to say we did it. This is going to be a lambda n, and we're going to do a Letrec for no good reason. There's not a great reason why we are doing this Letrec. We're doing a Letrec, and we're going to say A is equal to n, and we don't even need to do that. We can just use n directly. It is part of the environment, but we're going to force it here. And then we're going to say fact is a lambda that takes in a variable, and we ask the question, and you can put these guys down on multiple lines. If equal x1 boil down to 1, otherwise boil down to the fact of, well, boil down to multiply x times the fact of minus x1. And then in here I can call fact on A. Okay. Completely useless in this particular example, but I've created a Letrec, which is a let that supports recursion. I've given it a variable named A that is equal to whatever variable was passed in up here, n. I've created another variable called fact, and this guy is equal to a function, but it's a function that is defined in terms of itself. So this fact function calls itself within the local environment of the Letrec. If I change this guy to a let star, it's not going to work. Not enough horsepower. Make sense? We need the upgraded version. So that's our Letrec. So you really could make the argument that why don't I just do everything as a Letrec, right? Again, I would say only use Letrecs when you need to define a function that calls itself. What does a Letrec practically allow us to accomplish in a lot of our examples that we've done up to this point? A lot of times it'll allow us to not have to have a helper function, because we can embed our helper function inside of our function itself. Now, having said that, is that necessarily better? Could make your code a little harder to read. Maybe it makes it a little bit more transportable, where you can just say, here's a single function that accomplishes what you need, where your msort and your merge are all in a nice lambda. But the reality is things start getting a little messy in there. Does that make sense? So use a Letrec, don't use a Letrec. For right now, I don't think it necessarily matters. In fact, as you're getting used to the language, I think you will serve yourself well by writing helper functions. Keep things separate. That way, when you're looking at a function, you're focusing on what that function is really about. All right, so questions about let star, letrec. So we got three of these. We have let star, we have let rec.
Why is Letrec not spelled with a Q?
See, that's why I like some of these Apple software. It doesn't let me misspell things, because I have a tendency to do that. All right, so let creates a local environment where variables cannot be defined in terms of each other, and function recursion is not supported. Let star creates a local environment where variables can be defined in terms of each other, and function recursion is not supported. Steal this one. I should have done that for the other one. Let rec creates a local environment where variables can be defined in terms of each other, and function recursion is supported. Make sense? Now the good news is, because you now have access to these things, we can really up the complexity of the questions.
Oh, so you can like do a full language now, is what you're saying?
Getting pretty close.
Okay, that's great.
All right, so our homework for today, or for Wednesday, is going to be this exercise 1.31. And I'm going to explain it a little bit, because this guy is a little bit of, notice it's a 1-star question, but it kind of reads like stereo instructions. I promise you it's actually quite simple. When you're going through this one, we want to think about these functions as being kind of like constructors. So think about it like a object-oriented programming language. So we're going to write the following procedures for calculating on binary tree. And they talked about binary tree being 1.17. Ninja? So here's binary tree 1.17. So a bin tree is either just an int, or it's a list containing a symbol and 2 binary trees. Okay? This is the grammar for a binary tree. A binary tree is either just an integer or it's a list containing 3 elements, a symbol, and 2 additional binary trees. Make sense? It doesn't make sense?
Or you can continue.
Okay.
Ask later.
But that's what a binary tree is. This is the grammar for a binary tree. Go ahead.
What does bar do?
What is who?
Bar.
This is or.
Oh, I was looking down at the examples of such trees.
Oh, foo and bar. Those
Oh.
are just standard
Yeah, this is a
names
symbol.
for nonsense
This is a
functions.
symbol. This is a symbol. So here's an example of a tree 1. Here's another example of a tree 2. Here's an example of a tree where you have a symbol and 2 trees. Here's an example of a tree where you have a symbol, a number is one of your trees, and your other tree is a list that has a symbol and 2 trees.
I see.
Here's a tree where you have a symbol with 2 trees. Here's tree 1. Here's tree 2.
Gotcha.
Tree 1 is a symbol with 2 trees. First tree is just a number. Second tree is our second rule of our grammar. We have a symbol and 2 trees. And here's the second tree of our other one, which is a symbol and 2 trees. And the 2 trees are 4 and 5. That's what a binary tree is.
All right.
1.3. All right, so we're writing the following procedures for calculating on a binary tree. We're writing a constructor for constructing a leaf for a binary tree. So you've all had 300 where we write binary trees in there. A leaf node is just the number. Okay, so a type of binary tree that only has a number would be a leaf. We also have a constructor for an interior node. That would be the part of the binary tree that has a symbol and 2 other binary trees. So you're building a constructor, a function that takes in a symbol and 2 other binary trees. And what does it do? It spits out a definition for that binary tree. So both of these guys build binary trees. These are the core building blocks of binary trees. Make sense? Then we're going to have a predicate called leaf, which asks, are you a leaf? Are you a type of binary tree that is just a number? So this tests whether a binary tree is a leaf. Left sun, right sun, and contents of. So the left sun operates on internal or interior nodes, and it will give you the left binary tree, the left son, the left child of the binary tree. It's a little bit sexist, I guess. The children are always sons. All right.
On cells, they're always daughters, so it works out.
Our son is the right child. Contents of is the symbol. And this will extract the components of a node, an interior node. That's the guy. So an interior node has 3 things. It has a contents of, which is the symbol. It has a left sun, which is the first binary tree you run into. And it has a right sun, which is the second binary tree you run into. Contents of should work on both leaves and interior nodes. That makes sense? In fact, in the context of that last piece, if the contents of a leaf, well, I think it should give you the symbol. The contents of a leaf should be the number that's stored in the leaf, and the contents of an interior node should be the symbol of that guy. All right, so does that make sense what that guy is doing? You're writing several very simple functions that allow you to manipulate lists. That's what that does. There will be recursive calls as you have to break apart additional binary trees for your interior nodes. But these functions are not complex functions. That's why I want your mind to be in the mindset of constructors. Okay? Questions? Questions? What do I say?
Condiments?
No questions, comments,
Questions, comments, concerns, bribes. All right, I'll see everybody on Wednesday. Don't forget about Bible study tomorrow, 12 to 1, cafeteria, get free lunch. Don't forget about our tech talk on Wednesday. Don't forget about setting your calendar for next Tuesday, the 24th at 5 p.m. For CU launch. And if you would, message me on Slack if you're going to do CU launch so I can make sure they have enough food.